Okay, you're recording.
Let's see, open with Google Slides.
And why are you in Google?
Maybe that's why it looks different. But that's, do you see it?
We see it. Now try to go to full screen from view.
Yeah.
You need to go back to view. You're in insert.
Oh, there. Well, welcome to the Phi Sigma webinar series. We're recording so that we may be using it in our classrooms and for section presentations. I'll plan to use this in the Southern California area. So Phi Sigma, I think everyone on the chat understands Phi Sigma, that it honors and elevates achievements of students and professionals in food science and technology. We're a network of elected members and leaders on the frontiers of food science. It's worthwhile to join. So we all are about trying to bring this opportunity to people who are interested in food science and technology. We're fortunate that Joe Regenstein, who's been a renowned professor of food science at Cornell for many years, is now emeritus and still serving the community. This is the second webinar, and it's got such a wonderful title that I really look forward to hearing about it. Why I love factory farming. Dr. Regenstein.
Thank you, Connie. And yes, good morning, everyone. It's my pleasure to have an opportunity to talk about this subject. And hopefully by the time we're finished, some of you will hopefully have a more positive view of factory farming. And the reason, in one word why I like, or two words why I like it, is the next slide. It works. We've gotten to factory farming for the simple reason that the goal of modern agriculture is to provide sustainably food for the world's growing population. And that means we will and are doing things differently than our grandfathers and our founding fathers and all of those traditional terms that are still haven't been politically correct to make them. I guess it's our founding persons and our grandparents. But anyway, it works, and I hope to convince some of you that it is better than it's often pictured as. Next slide, please. I recognize this is a controversial topic. I am hoping to share information that is solid information. I will admit that in this talk, I am emphasizing, though not completely avoiding the negatives, but this is a positive view. And I think there are a great deal of misinformation out there. Hopefully, some of what I have to say will resonate and give you a better picture. Next slide. I thought this was an interesting quote. Normally, we celebrate those who can produce more product with less resources for less money. Well, that's what agriculture is trying to do, and that's how we got to factory farming. It makes sense. So let's continue. Next. Just to step back to the high plane of philosophy, morality, ethics, all those important elements. I did get to take a course in agricultural ethics some years ago. And one of the important points I got out of it was that to do these moral, ethical, philosophical discussions, you have to start by using reason. And so hopefully you will see the reasoning I'm doing and how I got to where I am. But I also recognize that this is a topic with a fair bit of emotional concerns among people that are legitimate and also need to be recognized, though I'm trying to work from the more reason, though I admit a little of my emotional reactions probably sneak in. Next. Okay, now let's jump in. In many of my talks on agricultural subjects, I describe my 5 core values, and they seem to be pretty universally accepted as the values of animal welfare, public health, environment and sustainability, impact on workers, and economics. And with those 5 goals or core values, we hope to have a food supply that is culturally, religiously, and ethnically appropriate for everyone. Obviously, my last talk, for those who heard it, and thank you for listening, was heavily focused on the religious aspects of making the food supply appropriate, but let's not also forget cultural and ethnic. And I guess as a basic value judgment, I do not consider it immoral to eat animal products. And obviously, some of you may disagree on that, and I respect that, and we can hopefully pleasantly disagree. Next. So one of the things I've done in many of my classes is ask the students to divide those 5 core values with 100 points. I mean, everybody's in favor of everything, but when you have a limit, how do you divide those 5 areas? And what's been interesting is that some of them have gotten a 0 from a few students, and the highest one area got was 70 out of 100 points. So clearly, individuals, we each divide these important values differently. Some consider them almost all equal. Others very much favor one or more of these at the expense of the others. And that's where we get into our conflicts. People with different rankings of these are going to take the same facts and look at them differently. And so, again, we'll see some of that as we go through this. But we still need good science, but we still have judgments that we make. Next slide. One of the things that bothered me as I began to think about these issues a little more is when there is a problem, what does it mean? Some people use problems to suggest that a system is a failure. That's really only true if we can't solve the problem. Animal agriculture has problems. It needs work to improve them. That is exactly the role of the scientists, particularly food scientists, agricultural scientists, when it comes to animal agriculture. And we need to work with the farmers and producers to solve the problems. It can be done. And we're seeing some very exciting science to try to improve the negatives of factory farming. And we'll try to cover some of those as we go through this talk. Next. Okay, that's the background. I hope it gives a framing and leaves room for people to disagree. And we'll discuss a number of different aspects of the topic of factory farming. And these are the main ones we'll be covering. Next. Okay, the fundamental thing that has driven my concern is the population. We're around 8 billion now, and will we go to 9.5? Will we go to 10 billion? We're going to have a lot of people. We already have a lot of people. And that means that we're using land for many other things: roads, housing, schools, factories, etc. In many cases, we're taking away agricultural land. The amount of agricultural land is essentially limited. Therefore, if we're feeding more people with less land, there's only one simple solution. We need to have a greater yield per acre of production. And I would argue that animal agriculture, because of some of its unique properties, can help deal with this. And that's the biggest part of this question of where are we going, is how do we deal with that? And if, I won't spend a lot of time on climate change, which is also going to challenge us to produce enough food with limited acreage. Next. Next issue is indoor outdoors. Yes, animals are outdoors naturally, but is that the best way for production? Next. One of the important things to think about is farmland does not, indoor agriculture does not need the most productive land. In fact, it could, in theory, be put on Superfund sites, on those areas which otherwise are unusable. In fact, we're now starting to see, mainly in China, as best I understand it, where they're building 10 and 15-story buildings with animals on each floor, in this case, pigs. So again, one of the things we see with indoor agriculture, which up to now has mostly been animals, is that even plant agriculture is beginning to move indoors. at least for high-value products, because one of the important points of indoor agriculture is control. Next slide, please. It's the ability to control the environment. That comes at a cost, but the fact is that it benefits the animals, benefits the owner. It does require greater responsibility for the owner, with more and more responsibility for the full stewardship of the animals. Interestingly enough, as animals become used to indoors, it is often less stressful, and we'll talk about stress in detail a little bit later, because they come to realize that there are fewer predators. I mean, there's still the small animal types of predators, but not the big major predators, and that they are living on better conditions. The question I ask my students, why are we all sitting indoors watching? Maybe one of you is lucky enough to be outdoors. Connie, maybe out in San Diego, it's warm enough to be outdoors today.
It is.
We're having a rain and relatively cold. I'm very happy to be sitting in my office indoors. Why should animals be deprived of that? Do you really think they love it when it's minus 30 with a minus 50 wind chill out in the West? Do you think they like it when it gets to be 100 degrees in Florida? No, they, like us, benefit from climate control, more humidity control, etc. Next. Eco services. One of the things that, again, people don't focus on is that, yes, we do raise corn and other grains to feed animals directly. But a lot of what we feed animals are the byproducts of plant and animal agriculture. So when you process all of these different plants to make sugar, to make corn products, to make wheat, you've got a lot of byproducts that can be used for multiple purposes, but probably the most valuable purpose would be to feed it to an animal to produce human food. Composting it is fine, but you lose a lot of its biological value. Burning it, you even lose more of its biological value. You're just recovering its heat. Obviously, there are cases where that's the best choice, but the fact is that animal agriculture uses an unbelievable variety of feedstocks. And the animal nutrition literature is filled with evaluating all kinds of possible resources. And the other part of this is that animal byproducts, and I'm taking what is probably the least desirable one, which is manure. It's been proposed for feeding. There's some real negatives to that, but it's a tremendous fertilizer. Or biogas. We can use everything from the animal. And when we evaluate the benefit of animals, we need to somehow figure out how to account for all the parts of these, not just the edible piece that is normally used for these calculations of, how much water the animal uses, and it's assigned just to the meat weight. It needs to be amortized over the whole thing. And I would point out, we are learning to do a better job of grazing, which is a better job of using the sun. The one major freebie that we all get is sunlight. Please be careful for the eclipse on Monday. But rotational grazing and improving how we use the land is part of what we're learning. But I would point out, the sun produces grass, and lots of our land is only grassland. Ruminants can eat and process the grass efficiently, though we'll look at how to do that even more efficiently. And humans can eat the ruminant. As somebody who's worked with fish all my life, I've always had the story of the little fish eating the algae and the plankton, and a bigger fish eating the fish, and then a bigger fish eating that fish, until you go through this loop of lots and lots of different fish eating each other and getting bigger. But each of those has a degree of inefficiency, which, again, having ruminants go directly to food makes it a much more efficient system. Next. So let's talk about another one of the controversial issues is stress. What we find is that when the animal is at some sort of an optimum, which we usually talk about not stress, but I would say an optimum, not a minimum, the animal tends to provide the greatest production, and that reflects, therefore, from the animal's perspective, the best animal welfare. If the animal is happy and is being productive, and I've used the word happy, I recognize that's an emotional term, but is not showing signs of stress and high productivity, that suggests that what we're doing to the animal is okay with the animal. Remember, animals do give us feedback, and that's partly the history of this development, was that farmers who all of a sudden have become evil when in the past they really were trying to make things best for their animals. Nobody wants the animals to suffer if they're going to try to make a living. It's a partnership. So one of the problems we ran into in some work I was involved in animal welfare standards is that sometimes people want to do measurements that are based on the average for an entire house. And one of the arguments our group, which was working with the supermarkets and chain restaurants, was that these kinds of issues have to be measured in terms of individual animals, not in terms of some group summary. And so even if the overall average is good, it is not appropriate to have some animals that are too highly stressed and or too low in stress. So next slide, please. One of the interesting things I had to learn, and it was not obvious to me or I hadn't thought about it enough, is low stress does not always equal good animal welfare. Complete freedom from stress is death. It's our reaction to stress that's important. So it's a question of how an animal is coping with the conditions in which it lives. As I often tell my students, when you go to class, especially in a class where a teacher will call upon you, there's a little bit of stress. When you're about to have an exam, your stress goes up. In many cases, that's good because that extra stress helps you do the exam. Again, an occasional student, and we worry about them, will be so stressed that they cannot function and will have a problem taking an exam. Again, we need to recognize that stress for an individual is our ability to cope. Next slide. This was a wonderful curve I became aware of, which is stress versus performance. And that's kind of what sums up what we've been talking in this little section, which is that there is an optimal coping capacity. I show it as fairly wide, and for most animals, there's a fairly good range. But low stress, an animal is bored, and we see that in all the stereotypies. And one of the things we've worked a lot on is trying to make factory farm housing more interesting for the animal, keeping it indoors, keeping animals separate from harming each other, but making sure they have things to keep them occupied. they'd actually do better. Obviously, very high stress, high temperature, low temperature, again, may lead to failure to cope, which again can lead to the worst possible animal welfare outcome, which is death. Unwillingly and under stress is not a nice way to die. Next slide. Okay. A lot of folks are moving towards outdoors and free range and pasture, and they have a number of problems. We brought the animals indoor to control the environment. We brought the animals indoor to give them safer space. We brought the animals indoors so that they're not eating contaminated soil. They're not eating things that they shouldn't be eating. They aren't sitting in their manure. As we moved away from caged laying birds to group housing, we're exposing the birds and their eggs to poop. And the poop has pathogens. Part of what we get out of cage layers, besides highest production of any system, is we get a safer food supply. Why are we working against that? Next slide. This is the most technical area I want to cover, but I think it's important, and I think it frames another aspect of intensive agriculture that at least my food science friends don't always seem to think critically about. So let's have the next slide and start this discussion. Think about what most of us eat every day. Most of us also have the goal of kind of retaining our weight. Yes, there are times when we want to gain weight. There are times when we want to lose weight. But hopefully, if we've maintained a healthy diet, we're trying to maintain our weight. That means we're eating food every day to maintain. It's not for growth. It's not for production. Obviously, during reproduction, women of reproductive age are producing a real commodity, but most of the rest of us are trying to maintain our weight, and yet we eat every day. And that maintenance energy is every day for every person and every animal. And so the more productive the animal, and I'll show you some slides from Jude Capper at Washington State, that the more productivity, the less the impact of maintenance. So next slide, please. So here is what we've been able to do. This is a dramatic example of what higher productivity does in the broad sense. We have fewer cows producing more milk, which has been the goal. The only place that it causes problems, by the way, is as we have fewer cows, we have fewer cows at the end of their production cycle, and we have less hamburger meat. And so sooner or later, we're going to have more hamburger made from food beef rather than cold cow. Next slide. So the carbon footprint of the average dairy cow has doubled since 1944, and it's done as CO2 equivalents. So the individual cow is much less environmental if you use this number. And this goes back to the old statistics don't lie, but statisticians do. But let's look at the next slide. And this is the carbon footprint per gallon of milk. Dairy cows are used to produce milk. And this does take into account the bulls and the calves, as I understand these calculations. but the carbon footprint of a gallon of milk has been reduced by 2/3. And that's the figure I would argue is the important figure, is what is a carbon footprint based on a unit of end product. That's what will show us that we've made progress environmentally and economically. Next slide. And here is an example of the dilution of the maintenance requirement. To produce milk yield of 50 pounds, the 10.3 maintenance, which doesn't really change greatly with production. Obviously, it can be fine-tuned, but for these arguments, we've kept it constant, which it essentially is. You're getting much more production as a percentage. Next slide, I think, actually breaks it into percent. Oh, yeah. So you've moved the maintenance from 40% of the food we're feeding the animal to 25%. That's a big savings when multiplied over all the animals that we have for milk. And the same holds for productivity of meat, which in that case is the faster we grow an animal, the fewer days on maintenance. And I'll come back to that in a little bit. Next slide. Want to tackle one that's a little more controversial. There is a wonderful book by Robert Blair on organic farming, where he looked at it and did a complete critical review of the research literature and found very little in favor. And here is a quote on organic farming from one of our Greenpeace folks. Were needed to improve organic farming. There is still a push for organic farming, but I would argue, and we'll have a few slides, next slide, next click, yeah. He was criticized by an African member of the FAO. Organic farming is practiced by 800 million poor people. They can't afford pesticides and fertilizers, and it's not working. Next slide. And this is land required. So please note the y-axis is land required. And this deals with this controversial issue, and I have mixed feelings about the use of a natural hormone that is found in the animals. But how much land do we need to do organic dairy product versus what we are now? And if we were to use RBST or something equivalent, it has an impact on the land we need per animal. So again, or for our total production, either way, again, organic's not the answer. We're tying farmers' hands behind their back. Am I in favor of all pesticides? Are we using pesticides properly? No, I'm not here to say that. On the other hand, as those who listen to my kosher talk, I would point out that the banning of insects for kosher means that some of the rabbis actually prefer the use of pesticides. But that needs to be balanced. But organic is not the answer. Next. And just to give BST a fair shake, it does increase the amount of BST in the steak, and this is a big steak, 6 ounces, 42%, which comes out to be 5.1 nanograms of BST in your food. By contrast, just again to frame what humans are doing, a birth control pill taken daily has 35,000 nanograms of estrogen. Women are taking that level of hormone on a daily basis voluntarily, but people are getting upset when and I but didn't write this as well as I should have, with, let's take the worst cases, that they've added 5 nanograms every time they've had a steak. 5 nanograms, 35,000 nanograms. Is there really a problem? Next, want to talk about grasses and grains, which comes back. Grass is a great solar collector. One of the sections I loved in Michael Pollan's Omnivore's Dilemma is the Joel Salatin basically seeing himself as a solar collector and working on rotation. Keeping land in grass prevents erosion. We're seeing that more and more with cover crops during the winter to keep things from eroding, but we still have problems with row crops and where we leave the land fallow during the winter. And we've talked about ruminants being only way to transform grassland. And remember that 1/3 of our agricultural land is only grassland. So turning questionable land or our forests into agricultural land is actually a negative. And I should point out, as somebody from New York State, which is a big dairy state, I ask my students as they drive to Cornell up and down the hills that it takes to get here, that do you really want to put plows and all the other aspects of crop agriculture on those relatively steep hillsides? Sheep and even cattle, depending on the steepness, can use that land in a way that pretty much no other agricultural benefit can be derived. So grass is very important. Next slide. Other downside of croplands is we kill more animals than on animal agricultural land. All that equipment goes through the field, killing small animals and birds. And one of the things I learned in my ag ethics course is that the animal rights people often work on the philosophy that all animals are created equal. Therefore, killing a mouse or a mole or a songbird is the same as killing a human or a cow. I personally don't subscribe to that, but if that's important, the fact is that those people who then argue for a vegan diet are actually probably killing more animals than those of us who are omnivores. And there's some numbers that Steve Davis at Oregon State has done to show
sorry.
that. That's okay. Next slide. As I've already said, the grain is often byproducts. Many of these byproducts cannot be fed directly to people. Some land might be better used to produce food for animals. One of the things we're going to have to learn to do is to balance our corn and wheat productions, et cetera, and some of the alternate sorghum and millet and things like that, how best to provide for the humans. One of the questions I raise that makes me unpopular at times with students, should we be returning to feeding pigs food waste? And I know they're also working on using food waste to grow insects. So can we do a better job of using food waste? And also, and this is where I get myself in trouble, feed all the feed or pet food in a supermarket. Think about the amount of product that is going to feed dogs and cats, which, yes, they're companion animals, but they also do a lot of pooping and they also do a lot of eating, and they do give off gases. Methane is coming from poop of all of the different animals. So are we feeding too much of our food to dogs and cats and other companion animals and spending tremendous amount of money these days and redirecting veterinarians to work on dog and cat and not being able to work on animals, farm animals? So do we have some issues there of balancing what we're doing? Next. So the point I want to make is the second paragraph. What it turns out from work by Jill Capper and others is the faster an animal grows, the fewer days on maintenance. We understand how that's an advantage. One of the other things that has been shown is if one, even while animals are being grass-fed, do a little bit of supplement with grain byproducts, the methane per day goes down. So it's a double whammy. You have fewer days on maintenance, and you have less methane per day if you speed it up by feeding grains. Again, different way of looking at it. One of the issues with corn has been this question of food versus fuel, which is probably more of a political statement than a scientific statement, because of course, cattle are not good digesters of starch or plant carbohydrates in general. And by producing alcohol from starch, you remove the starch, and the remaining material actually is more nutritional for the animal. And especially if you don't have to dry it, you save a lot of energy. And one of the things we need to work on is how to put the ethanol factories near where the cows and sheep are so that we can save on the drying of this. But it is not about fuel versus food. We need to get the proper balance. Next. Next slide, please. We're learning how to control methane. We're breeding for it. We're adding feeds. We're looking at gene editing. And we're also, to do a better job, we're looking at Holstein beef, and we're seeing crossbreeds so that the males are valuable also and are not going just for young veal. So again, factory farming isn't perfect, but animal agriculture has a role, and hopefully we're doing a better job as we go along. Next. Grass-fed animals grow slower, so more days on maintenance. And is that the right way to go? Next slide. Solar energy. We're seeing better use of our solar collectors. Can we graze animals underneath instead to deal with the grass that's growing? In fact, I would argue we need more sheep and goats everywhere. Someday, Cornell will have sheep and goats and stop using lawnmowers, especially the gas guzzling lawnmowers, which are actually one of the worst offenders in terms of environment. My future goal is that only goats can prevent forest fires. They'll eat everything on the bottom of the forest and lower the fire hazard. And they'll eat your poison ivy too, as an aside. Next. We're doing some interesting things with solar, using them to produce water in areas of drought. introducing fancier systems of shading to grow crops and use them as climate change, harvesting the sun and sunlight both for plants and electricity. Next slide. I think I've got a couple of pictures of systems. Here is a system where they're doing row crops under solar collectors, using them in part to control the amount of sunlight in the appropriate amount. So again, multiple use. Next. And again, these are the crops from on high. And you can also, if it's lower with sheep and goats, can get underneath and eat the grass. Again, not thinking of them competing, but as working together. Genetics and behavior. Next. Animals in the wild have behaviors that, when they go into captivity and indoor agriculture, they may not need them. They've been bred, hopefully, to have a better personality in group situations. And I would argue with this word natural that we keep hearing about, I would argue that no plant or animal that is domesticated is natural. And therefore, again, their behaviors and other needs need to be dealt with in the context of what they are really, not what they were once upon a time. Next. Places where I will fault modern agriculture is breeding. We have been too selective and going for production traits without thinking about the whole animal, such as leg weakness, sociability, things of that sort. One of the beauties of modern computers is we can begin to track more factors and do a better job of breeding. It's an area where work is needed. Next. And finally, human health. Again, this is not an audience where I have to overemphasize this. I think you know. Again, moderation, including animals, is part of what we need in our diet. We need to eat the right amount of meat, which is probably in the neighborhood of 3 ounces of lean meat a day. We eat way too much. I'm willing to admit that hopefully that excess meat eventually will go to feed people around the world. Next slide. And these are some of the contributions of meats. Again, I realize with time I'm going to just list them, and I think most of you understand them. Next slide. Next slide, Connie, please.
Oh. It's kind of froze. Let's see. There we go.
Trace nutrients. One of the things we are learning is that the alt meat products are not necessarily nutritionally equivalent. In the food industry, we used to have to call them imitation products. Imitation crab, for example, as a fish person. They have their place, but we need to think about them nutritionally more sophisticated. Next. Again, antibiotics. We are doing a better job of controlling them, of not using them for the same drugs as are important for humans. We have ionophores, which are of no human use, which are classified as antibiotics. The question is using antibiotics properly, which FDA has done a really good job of changing that in agriculture, but we still have the issue of pet owners and humans themselves not finishing antibiotics once they feel a little better, which helps with antibiotic of microbes becoming antibiotic resistant. We need to now switch to working on humans and pet owners to use antibiotics as carefully as we've made farmers do. Next slide. And we're also doing more substituting of antibiotics with feed ingredients. Next slide. And finally, directly on animal welfare, next slide, is death naturally is generally more painful than slaughter. That doesn't mean that we can't do a better job of slaughter, and I'm spending a lot of time on that these days in my emeritus status. But we grow animals for food. It means we have to slaughter them, and we have to come to terms with that. Next slide. This is from Temple Grandin pointing out, particularly being hunted down by a wolf is really bad. Wild animals treat other animals poorly. Next slide. Let's skip that. We've talked about byproducts. And thank you. That's the last slide. Just two things. Believe nothing that you think. And for every problem, there's a solution, which is simple, clean, and I've added sometimes wrong. Mencken said it's always wrong. Next slide. And with that, thank you. And I'd be happy to answer questions, happy to take questions by email in the future. And I know this set will be posted, but I'm also happy if anybody wants a copy of the slides. I'm always happy to share my slides. I do not consider them proprietary in that sense.
Well, thank you for sharing all those years of wisdom and refining these ideas with your students. I know I have a lot of questions, and probably the audience does too. Well, let me start with one, and I'll open it up to others. So I was asked to debate last fall at the FNCE, the dietetics meeting, cow's milk versus plant-based beverages. And afterwards, someone came up to me and said, well, you didn't include the concept that dairy cows feed on grass, and that's a different use of water that comes from rain than, like, say, almond trees that dig into the groundwater and siphon off irreversibly water. I haven't heard that argument much, but that was an interesting idea. Have you thought about that?
Well, I worry about water a lot, and there was an article in the last week that almost I'd have to say came close to blowing my mind, where somebody has done a piece of research where they've shown that in cover crops instead of row crops led to, and then having animals eat it, led to lower total water usage and a better economic return for the use of the land. So again, I think we need to look at very carefully, not just total water, but where we get our water, how we use our water. I think there's the whole area of water usage on both plant and animal agriculture. One of the things I became aware of a few years ago, for example, is that Israel has an entire nationwide grid system for gray water.
Wonderful.
We need to make it safe, and we need to be aware of our pathogens, because that's been part of our problem in plant agriculture is our irrigation water is sometimes spreading the pathogens. But on the other hand, we have a tremendous amount of gray water that ends up going into sewage treatment plants, which are expensive and to run and may not necessarily need to go there. And how do we optimize? I mean, when you go in a plant, a lot of plants are doing a great job of less waste of water, but that water that is wasted is not always well used. Now, some are recycling it, but there's a lot of room for the science community, including us in food science, to do a better job of water management and a better job of understanding the implications of different kinds of water. Drawing from the aquifer is very different than rainwater, as you very well made the point. Gray water from a plant should be somehow bookkept very different than taking it from the municipal water supply. And how do we make those calculations? And part of that is, how do we value water? And one of the things some of us probably would accept is that water is undervalued because it's a common property almost item with a little bit of a charge for the piping and the chlorination, but the fundamental material is treated as a freebie. And we may need to rethink how we do this also.
It seems like New Zealand is a step ahead, because they're already using sheep to mow the golf courses instead of the lawnmower, like you said. And my collaborator, who's a kinetic modeler, spent several years in New Zealand working on this modeling system called Molly. And so they plotted weather patterns and fertilizer use and whatnot to try to optimize milk production of cows. So to know when to augment the grass with cereals and so forth, to fine tune use of water and other resources.
That's what we need. I mean, one of my colleagues, Gary Fick here at Cornell, has done some very interesting calculations, basically at each state level. And he has looked at how agriculture needs to be balanced between plant and animal and some parts of it in order to give the maximum number of people the USDA minimum requirements. And again, we can argue not all of us are totally enamored with all the details of the US, but it was an objective standard. And in some states, literally you had to shut down animal agriculture. And in other states, you probably need to increase it. Again, we need to do more, not really micromanaging, but we need to not think about the cattle industry in America. We need to think about the cattle industry in Eastern, Central, and Western New York State, and even possibly more, as to what we optimize, how many animals on the land, what water, how that impacts water usage, how it availability of byproducts, what are we doing with the fertilizer? And that one of the challenges of CAFOs is that they have more manure. 10 farms with 80 animals has just as much manure as one farm with 800 animals, and the 800 animal farm can afford to do things that the 10 farms with 80 animals can't do.
Mm.
So the biodigesters are going to end up on the 800 animal farm, not on the 80, until those 10 farmers come together and say, we too will do an 800 animal biodigester. So again, big and small also impacts what you can do. On the other hand, the 10 small farmers probably can do a better job of spreading on the land, whether that's good or bad. And that gets into some aspects of agriculture I'm not as knowledgeable, but the big farm may not have enough land to spread. Is that good or bad? Lots of much more detailed, nuanced questions to be asked in terms of facing the future, which we've got to do, and we've got a lot of people to feed.
I welcome anyone to chime in with a question. You could put it in chat, but this small group, so feel free to jump in. Otherwise, I'm going to ask more questions. So what do you see as the future acceptance, and especially among those who have philosophical barriers to eating animal products, of cultured meat factories?
That's a fascinating question. Um, I think we're going to see a lot more resistance to cultured meat in general. I'm not sure that those people who object to animals are actually going to find that they actually want to eat a steak, but they just want to eat it coming out of a fermentation vat. Um, I'm struggling with what is this really going to mean? Um,
Oh, Joe got frozen. Uh-oh.
to
Well,
to the vegan, I think it's still an animal product. With carnivores, are we willing to eat these products? As this becomes more,
Joe, you're cutting in and out. I think the rain you've got described at the beginning is interfering with your signal. We may have to end. It's just over the hour anyway, and probably time for people to have to move on. Thank you so much, Joe. Thanks to everyone for joining. And until
Thanks
next
for
time.
moderating. Thanks for moderating, Connie. Good job. Joe, always great to hear and see you.
Thank you, Stephanie. Bye, everyone.
Bye. Bye-bye. Thank you.
sorry, I lost my connection. I guess people do need to get on with their day. I went a little bit long.
No, that's fine. It was really an interesting area. Thanks for being brave enough to tackle it. You always have been wonderful at bringing non-traditional ideas and points of discussion. You've never been afraid to dive into what's sensitive and controversial. That's a great role.
When I was young, we had a professor here. Well, he's passed before me, but one of the mottos we heard is a professor is someone who thinks otherwise. And I've always taken it to heart. It fits my personality. I do like being controversial.
I really worry about institutions that are taking steps to eliminate the freedom for professors to be controversial.
Yeah.
We have to worry about that most of all.
Well, you're looking at somebody at one time was called by the state apple growers public enemy #1, and they went after me at the university.
Oh, apples? Like they thought you're against apples?
Yep, because I was telling people that they're coated with animal product, which they didn't know what their own industry was doing.
Oh, that's funny. What was the product?
They were using tallows and lards as
Oh,
part of the coating of fruits and vegetables.
that's hilarious.
And that's the whole story of my the Nutritional Labeling and Education Act having the produce waxing rules, and the supermarkets having a sign of which fruits and vegetables are coated. That was my doing. I almost thought it was a memorial statement.
Thanks for that extra insight. Have a good rest of your day, everyone. Bye.
Thank you,
Bye
Joe.
now.